mag-start na, hindi ko kita.
Okay na, pre.
Start na?
Okay na.
Okay na.
So, experiment number 9, charges. Objectives, determine the variables that affect the strength and direction of the electric field for a static arrangement of charges. Number 2, investigate the variables that affect the strength of electrostatic potential or voltage. Number 3, explain equipotential lines and compare them to the electric field lines. Verify the prediction using vector addition. So for number 1, drop a positive charge onto the middle of the positive charge box below and draw the field lines. So ilalagay yung positive. So miss, nilagay na po namin yung yung drawing, and as we can see po, yung arrows po or the yung yung field strength po palayo po dun sa positive charge na ayun po. Next is clear the field and repeat procedure with a negative charge po. So ilagay din po kami doon kasi yun po yung arrow po papunta po doon sa negatively charged ion po. For number 3, so drag and drop sensor at least in several are charge. Use the voltmeter to determine the electric potential of each location, labeling each spot as you go. Be sure to include the sign of the potential. Repeat the procedure with a negative source. So, ang gagawin, first is positive, then maglalagay po ng mga sensor. Naglagay na po kami, miss, ng mga sagot po na. Then, as ang makikita po sa simulation, yung sensor, yung arrow po is palayo din po. While sa negative charge ay papunta po dun sa yung arrow sa ion. Number 4, and drop negative and positive charge ion. So ito po yung nagiging itsura nun. Negative sa taas, positive sa baba. And as we can see po, yung arrow po, yung sa positive charge po ay palayo, then yung yung palayong arrow pong yun ay papunta po dun sa negative charge. So for number 5, pabasa nga Yuval. Yubs? Labas si Yuval? Kuya Wilmar, kayo na lang po muna.
Okay, ako na lang siguro. So for the number 5, use the voltmeter to locate a line of zero potential difference and draw the line on your field map above. How do you explain the existence of zero electric potential where the electric field is not zero? So the answer na po is the existence of zero potential is between the positive and negative charges because the electric field moves to the negative parts. There is still an electric field.
Yan. So number 6, Lennard.
Number 6, ma'am. Move the charges closer together and note what change occur, particularly with respect to the field strength farther away from the source charge. Yung sagot po namin ay, the change is that when they get close, their electric field has nowhere to go because their forces just fit together and their equipotential value is 0. When each field field strength is farther away, the field strength is clearer. The electrical field strength is from positive charge to negative pole. And the position is from the bottom to the
Ano
top,
ba yung mahina
negative
yung
pole.
signal?
So all the intensity of electric field goes into the top.
Yun. Mahina ba signal ko? Choppy ba ako?
Okay naman yan.
So akin pre, nagchuchoppy.
So,
Talaga.
next, number 7. With the charges. Ha?
Ako nagchuchoppy ako pre. Yung ano, yung
Choppy?
boss sa akin, choppy kayo. May natol lang sa akin.
Eh, sa iyo, Kuya Wilmar, choppy po ako.
Hindi naman okay lang.
Parang mga nagsihina po yung mga signal natin.
Oo nga, maulan siguro. So, continue natin.
Hello, kuya, narinig niyo ako?
Okay. Hello?
Hello.
Lahat tayo may na-signal.
Yun na, continue siguro.
Yan, continue na. Number 7. Number 7, with the charges close enough to just touch each other, slowly move the voltmeter along the horizontal line located roughly along where the charges meet. What happens to the meter reading as you get nearer the edge of the field? So our answer, miss, is the closer the voltmeter is to the middle of the intersection of charges, the higher the volt power or volt force, and the closer to the edge of the electric field, the lower the volt force. So number 8, Yuval, pabasa.
Lay one source charge directly on top of the other. What happens to the field? When we put one source charge directly on top of the other, the field will be stronger depending on the charge you place on the top. The force will increase the negative or positive force. When you place a negative source, the field will have a negative force unless it is close to a positive charge and vice versa.
Yeah. So number 9, Kuya Wilmar, pabasa po.
So for the number 9 po, what are the implications about field strength at a location far enough away from these source charges that they appear to be atop one another? So for the answer po, when the force is far from the source charge, the force of the force is the weakest. It also shows the movement of force even if it is far from the source. A field above a negative charge shows a negative force, and a field above a positive charge show as a positive force.
Yeah. So for number 10, set the field and drop two negative charge in vertical line with one charge near the top of the field and the other is near the bottom. Draw the resulting E field. So may nilagay na rin po kami drawing doon, and as you can see po, yung arrows po, may arrows na nakaturo po sa taas or dun po sa negative charge po sa taas at meron din po sa pababa. So number 11, Lennard, pabasa.
Is there a place where the field equals 0? There is no place where the field equals 0. Why isn't or is there such a spot? Two negative charge act on each other and the two magnets have the same charge. So there is no contradictory force between the two negative charges.
Choppy. Yan. So moving on, number 12, Yuval, pabasa.
Okay, 12. Considering each field that you work with, does there does there appear to be a relationship between field strength at at any location and electric potential at that spot? The answer is yes. If you believe there is a relationship, how would you summarize it? The potential is also called the voltage. The exact relationship between electric potential and field strength is the direction of the electric field lines along the direction of the voltage. Because the electric field pro- propagates from high potential to low potential, it is like the concept and field of gravitational potential. The experiment that summarizes the relationship between electric field and voltage is the change in the flow of electric charge from a point of positive charge to a point of negative charge. Yun po yung sagot.
So for the conclusion, pabasa po kayo, Wilmar. Naka-off mic po kayo.
Sorry. So for the conclusions po, the field strength in terms of the two variables that affect it, the strength of the electric field depends on the amount of charge in the source charge and the separation distance between the charge and the source. The inverse square relationship between the electric field strength and the distance is a characteristic of the electric field strength. The intensity of the electric field formed by the source charge is proportional to the square of the distance between the source and the observer. On the straight line between the two charges, the electric field is constant. Along the curved line of the electric field, the electric field is not constant. The equipotential line connects the place with the same electric potential. All electric fields lines are perpendicular. Sorry po. Perpendicular to all equipotential lines. We predict that the electric field of the source charge will exert a force on the test charge in the field. If a positive test charge is placed in the field, the electric field vector will point in the same direction as electric energy of experiences. There are many field vectors to observe. As with all vectors arrows, the length of each vector arrow is proportional at the field strength of each locations. So yun po.
That is all, miss po. Salamat po.
Thank you po.
Thank you,
Thank you,
Miss.
Miss.
Thank you, Kuya Wilmar. Thank you, par.
Salamat
Thank
po
you,
sa inyo. Thank you.
Stop
Thank you,
recording.
guys.
Thank you sa inyo, pre.
Sige po.
Bye-bye.
Bye-bye
Salamat
po.
sa inyo, guys. Ingat-ingat. Salamat. Bye-bye.
Ingat
Sa
din sa inyo.
ulitin. Thank you. Ingat kayo.
Ingat
Ingat.
yung